Hello everyone, this is a video tutorial on Linux file system encryption. This tutorial addresses data encryption for your GNU/Linux system. The concepts presented in this tutorial can also be used to prepare and install an encrypted GNU/Linux system. In this tutorial, I will be explaining some of the concepts of file system encryption and the methodology of the Linux Unified Key Setup encryption specification. In addition, I will be showing you how to perform data encryption on your Linux platform and how to access and use an encrypted file system on your GNU/Linux system. Finally, I will be showing you how to perform secure erasure of your data to ensure that there is no remnant data left behind that could be compromised later on. The purpose of encryption is to secure information by converting it into a ciphertext that is undiscernible without a key to decipher the ciphertext. This prevents unauthorized access to information by requiring the key to decrypt the ciphertext into discernible information. Encryption is a security mechanism that protects against physical attempts to access the information. However, encryption only provides security against physical attacks. It does not protect against viruses, trojans, or malware, nor does it protect against network intrusions. Furthermore, encryption security is only as good as key management. Weak passphrases and irresponsibility in managing key files will not provide strong security of your encrypted information. It is important to note that files that are transferred from an encrypted file system to an unencrypted file system no longer remain encrypted on the unencrypted file system. It is necessary to securely erase your data from the unencrypted file system to ensure that your information is not compromised later on. The Linux Unified Key Setup, also known as LUKS, was developed as an encryption specification in order to standardize the encryption process between different Linux distributions. LUKS specifies usage of dmcrypt and crypt setup for file system encryption on the Linux platform. dmcrypt is part of the Linux kernel and serves as the encryption backend during the encryption process. It supports all popular encryption ciphers including AES, Serpent, Twofish, Blowfish, Triple DES, and DES. Crypt setup serves as the encryption frontend and is usually installed on most distributions. You'll need to be sure that crypt setup and its dependencies are installed for the next segment. In the next segment, I'm going to be guiding you through the file system encryption process. The commands that I will be using have been posted in the description box for your convenience. The first step is to prepare the drive that you will be setting up the encrypted file system on. For this tutorial, I will be using a 1 GB flash drive that has been used previously. Previously used drives need to be overwritten to securely erase any existing data that may remain on the drive. In addition, new drives need to be overwritten as well, as they may be completely filled with zeros. This would allow for someone who is examining the hard drive to distinguish the encrypted data from the unencrypted data on the drive. Therefore, it is important that we overwrite the drive with a stream of random data in order to prevent anyone who may be examining the drive from being able to distinguish between the encrypted portion of the data and simply random data that is residing on the drive. The first step to set up an encrypted file system is to connect the drive to the computer and open up a root terminal to see where the drive has been loaded. At the root terminal, type in ls/dev bar grep sd. And in this case, you can see that the device is currently loaded under SDB. Now the numbers after the device indicate partitions that reside on the physical device. And in this case, SDB does not have any partitions currently set up on it. So the next step is to wipe the drive completely with zeros and with a pass of random data to ensure that the device is completely erased and that random data is on the drive in order to hide and prevent someone from distinguishing the encrypted data from just empty data that resides on the device. So we're going to do this in two passes using DD. For the first pass, we're going to input data from the 0 block device and we're going to output it to the drive SDB using a bit size of 1 MB. Now, if your drive currently has partitions already existing on it, please be sure to just type in the physical drive itself, excluding any partitions. So if your device is SDB and there's 3 partitions on it, just type in SDB without the partitions. This will completely erase the entire drive that you're going to be setting up the encrypted file system on. If you do want to encrypt only part of the drive for setting up a file system, please be sure to just type in the drive as well as a partition to erase only that specific partition. But in this case, I'm going to be wiping the whole drive. Now, the process of wiping the drive with zeros will take a very long time, and the length of the time it takes to wipe the drive will be dependent upon the size of the drive. Drives as large as 4 terabytes can take well over a day to complete, so please be patient as this process is working, because it will take a very long time and you won't notice any changes on the screen as it doesn't provide any feedback. But rest assured, the program is working, and once it has been completed, it will give you a result of the information that was wiped. So for now, I'm going to cancel this because the drive has already been prepared for this tutorial, and I'm going to proceed with the second wipe phase, which would be the device of the random block. So in order to wipe the drive with random data, type in dd, and you're going to input data from urandom and output it to SDB with a bit size of 1 megabyte. And in the above command that I typed in, the 2 ending characters, the exponential and the C, is just the cancel command that I executed to prevent from wiping the drive. So once again, I'm going to cancel this as it's already been prepared. So I'm going to cancel that command and proceed to the next step. So once the drive has been completely wiped with random data, your drive will be ready to set up a partition. So we're going to use parted for this process, and we're going to type in the command parted space dev /SDB. Please be sure to specify the device so that parted knows what drive you're going to be using. Otherwise, it will default to its first device it sees on the computer, which will most likely be the primary hard drive on the computer. So the first step, what we'll need to do is we'll need to make a label for the drive. So we're going to type in make label, and in this case I'm going to be using the traditional MS-DOS label. You can use GPT label if you want, but you'll most likely want to use MS-DOS. After this, what needs to be done is a partition needs to be set up on the device in order to set up the formatted encrypted file system. You could also set up LVMs, but I'm not going to do this in the tutorial. In order to do that, simply consult how to set up an LVM, and the process will be pretty much the same except for setting up the LVM portion. So to set up a normal partition on a MS-DOS labeled drive, type in make part space primary, and I'm going to be using percentages to indicate partition size because it is easier to determine the actual size that I want to be using. I'm going to use the whole device, so I'm going to start with 0% and proceed to the end of the device, which is the full 100%. You can also use different sizes for this, such as kilobytes, megabytes, gigabytes, etc., to indicate the start and the finish, which in this case would be 0% and 100% respectively. Now that the partition has been created, I can type in print to verify the work, and you can see that I now have a 1 gigabyte partition set up on the drive. The next step, what I need to do is actually proceed to set up the encrypted file system, and for this purpose I'm going to be using crypt setup. So crypt setup command, what I need to type in is crypt setup, and I'm going to type in lux format to specify that I'm going to be formatting the SDB1 partition. Verbose will provide output feedback. Cipher will specify the cipher algorithm that I'm going to be using. In this case, I'm going to be using AES, which is the most commonly used cipher algorithm that is used mostly. Older systems use other ciphers such as Blowfish, but this is the most recent and standardized encryption algorithm as to date. So I'm going to be using AES. You need to type in XTS and plain 64. 64 is required for devices that are larger than 2 terabytes in size. In this case, I'm going to be using only a 1 gigabyte drive, and this will work for this size as well. But if you're going to be using sizes of 2 terabytes or greater, you will need to use plain 64 as opposed to plain. If you are using a 30-bit 2 computer with a 32-bit operating system, the plain 64 is required as well. This has nothing to do with the software architecture that is used. I'm going to be specifying a key size of exactly 512. Hash size is going to be secure hash algorithm 512, and I'm going to verify the passphrase that I type in. And finally, I'm going to be specifying SDB as the device that is going to be encrypted. And the partition specifically would be the first partition. Once I've typed in that command, press enter, and it's going to prompt me to be sure that I want to create an encrypted file system on this device. Type yes in all capital letters, and type in your passphrase. And now I have an encrypted file system set up on this device. Now, the encrypted file system has been set up, but at this point there is simply an encrypted container which does not contain an actual file system on it. What this means is that you will not be able to utilize the file system to store information on it until a file system has been created within the encrypted container. So the next step would be to make a file system on the device, and in this tutorial I'm going to be creating a file system using fourth extended file system, or ext4. You can also use other file systems such as the experimental B-tree file system, or other file systems like Riser or NTFS or FAT32. You will just specify this at the point of creating the file system. So at this point, what I need to do first is I need to actually map the device onto the computer, which basically allows the device to be interpreted through the cipher block and unencrypted so that it can be utilized before I actually set up the file system on the encrypted container. So what I need to do is I need to type in crypt setup flux open and I'm going to specify the drive that I'm currently using, and I could use any arbitrary name to map the drive, and in this case I'm just going to use new drive, and I'm going to be prompted for the passphrase at this point. Now my drive has been currently mapped to the computer, so my drive is currently going to be under the device mapper, and it will be available for access on the computer now. So at this point, what I need to do is I need to make a file system, so I will type in make file system. Type in this example is going to be for the extended file system. In other cases, you could type in VFAT for FAT32, or for example, you could also type in ext3 if you wanted the third extended file system, and others as well. I'm also going to type in M option with the number 1. What this indicates is I'm going to specify a 1% reserve for the root user on this file system, as opposed to the default, which is a 5% reserve on the file system. Since the default of 5% can be a very large reserve amount for drives that are 1 terabyte or larger, this becomes impractical and takes up a lot of space that could be utilized by the user, but is reserved for the root, which basically wastes a lot of space on the drive that could be used in practice. So the 1% will significantly provide more available storage for the user. So I'm typing in -M1. And in most cases, for drives that are auxiliary to the actual operating system, this is what you want to specify when setting up a partition and creating a file system on as well. So at this point, I'm going to specify the device that I'm going to be creating the file system on, which is device mapper, and in this case it's going to be new drive, which I specified in the previous command. And as you can see at this point, it has successfully created the file system on the device. So now what I'm going to do is I'm going to mount the file system to make it accessible to the user on the operating system. So what I'm going to type in is I'm going to type in mount, type specifying for the extended file system, and I'm going to mount the device from the device mapper to a directory I have set up, which is mount new drive. And the last thing that was typed in, which /mount/new drive, is a directory where the file system is going to be mounted. So now you can see that I have my device successfully mounted in the directory mount new drive, and it is available for access and use. Down here I have the file already open, so I can reload, and you can see I have the new file system set up, and it is available for usage to begin storing information and encrypting it on the computer. So at this point, what I'm going to do is I'm going to show you how to properly dismount the drive or unmount the drive and remove it from the device mapper so it could be properly removed from the computer. So first, what you'll need to do is you'll need to unmount the device first. And then you'll need to remove it from the device mapper by using crypt setup. Type in crypt setup lux close, and be sure to type in the name that you specified initially. Now you can see my device is currently removed from the computer and is no longer available. At this point, I'm going to review how to access and use the encrypted file system from the command line, as well as show you how to access and use the encrypted file system from the graphical desktop environment. So for the command line, I will type in crypt setup lux open, specify the device that needs to be mounted, and give it an arbitrary name to mount it under. And it will prompt me for my passphrase, which I will type in. Now I will need to mount the device which has been mapped. And I can specify the directory I want to map it to or mount it to. So now my device is currently available under mount old drive, and you can see it's available. Now I'm going to remove the drive by using the same steps but in reverse order. So I will need to unmount, and then I will need to use crypt setup lux close to remove the drive. Now the device is unavailable and I can no longer access the encrypted file system. Now using the command line is easier, but it does not give me the flexibility and the manual control that I have using the command line. For example, I won't be able to specify where I'm going to mount the device. So it does give advantages, but it has that disadvantage as well. So in order to access the file system, there's an icon on the left panel here which provides me with the option of mounting and opening the file system. So I can right click and mount it, and this will automatically map and mount the device for you by just typing in the passphrase. And I'm going to have it forget the passphrase. So now you can see the device is available to me, and in order to unmount and remove the device from the map, I will simply safely remove the drive. So I have successfully mounted and unmounted the encrypted file system, and it is no longer available for use on the system, and it is unavailable to people who have access to my physical drive. However, if I copy files off the drive from the encrypted file system to an unencrypted file system, there is a possibility that those files could be compromised. So I'm going to show you in the next step how to successfully remove those files from the unencrypted file system that may have been transferred during your work. So once the device has been mapped and mounted, I'm going to use the command line to set it up. What I'm going to do is I'm going to go to the directory where I've mounted the drive, and I'm going to make a new file which I will call my new file, and you can see my new file is currently there. And what I'm going to do is I'm going to copy my new file to a temporary folder on the unencrypted file system. So you can see my new file is currently on the unencrypted file system. So what I want to do to securely erase the data from the unencrypted file system, I'm going to need to shred the data by overwriting it with several passes of random data, and finally with a random pass of zeros to make sure there is no remnant data left. So I will type in shred, then I will type in remove, specifying a final zero pass, and request verbose, and I will specify the file that I want, which is my new file. And as you can see from the output, the file is no longer on the drive and my information is now secure. So I can safely remove the drive from the computer and be rest assured that my files are no longer available on the unencrypted file system. So this concludes the tutorial for Linux file system encryption. I hope this information has been helpful to you, and if you have any questions, please feel free to send me a message and I will be sure to respond to you. Thank you very much for watching.